Let's talk about NumPy. NumPy is nothing but short for numerical Python. It's a specialized library which is meant for working with numbers. Okay, let's look at the definition. It's a long definition. Large multi-dimensional arrays, lot of words. These are the keywords. We're talking about large arrays and matrices and lot of function. Let's look at the same thing in a different manner. We have regular Python and we have NumPy. In regular Python, we work with list, and NumPy we work with arrays. Now, how these two are different? The difference is that list can contain different data types for each member. You can have one number, second string, third float, and so on. But in NumPy, all the members of the arrays have to be of the same data type. What it means is that while list, they have to maintain data type for each member, arrays don't have to maintain data type for each member. This is the key difference. It means that regular Python lists are good for general purpose use, while arrays are specialized. Why these are specialized? Because regular Python lists are slow, NumPy arrays are fast. Regular Pythons are very heavy on the memory. It takes a lot of memory. So as your list grows, as the number grows from hundreds to thousands to even millions, lists will make your system very slow. They take up a lot of memory. They become very, very slow. But the moment you talk about arrays, arrays can work with millions of members very easily. That is the importance of NumPy. Now the next question is why you should care about NumPy. Are you going to work with NumPy all the times? Not really. NumPy you learn the fundamentals, but all the data science machine learning libraries, for example, Seaborn, Matplotlib, PyTorch, Pandas, Keras, TensorFlow, all these machine learning libraries are actually using NumPy as the base. All these libraries are built on top of NumPy. If you don't know NumPy arrays, how NumPy works, how NumPy arrays, NumPy functions, matrices work, then it will be very difficult to understand the fundamentals of all these libraries. Enough of theory, let's get started with actual code. I've opened a Jupyter notebook, and if you're not comfortable with Jupyter notebook, you have to learn it. I'll leave a link in the description for a video that will get you started. Okay. Once you're ready with Jupyter Notebook, open a new notebook just like this and import NumPy. Import NumPy, and by convention, let's use it as NP. Before we start creating arrays, let's revise list. Here is a list 1, 2, 3. Okay, fine. I can print this list, or actually I can have multiple types of data. For example, one is number, this is a float, and let's make it a string. It can have it. And if I want to check the data type, let's check the data type of the first one. First member is int, the second member is float, and the third member is string. This is possible, but in arrays, it is not possible. Again, the question is like, how do we create arrays? Let's create arrays. The simplest way to create array is to create a list. I'm going to create a list with one type of data. Let's say I've created this list, and this is a list. What we can do is we can call np.array and send this list. That's it. We have created our array. What happens if my list is actually having, let's say, a float and a string? This is my list. In that case, if I try to use np.array, what it will do, it will change the data type, everything to the same data type. Here you can see that the data type is, for every item, the data type is string. And you can see that data type is listed as U32, which is Unicode 32-bit. Now this symbol actually means little endian if you want to go into that. What we can see here is that there was one string, it had to convert everything into string. If there is no string, then what happens? As you can see that the largest data type was a float. Now everything is converted into float. Now how do we know that it is a float? You can see that if there is no value after decimal, then you will just see that only the decimal is printed. This is how NumPy actually prints float. Now this concept where the data type has been changed to a larger data type that can fit all the values is called type promotion. What type promotion does? It ensures that the data type for every member does not have to be stored separately. Now, if you have the question that why the data type is not printed here now, okay, when we had a string here, the data type is explicitly printed here. But let's say if everything was integer, this data type was not printed. If it was a float, that data type was not printed because NumPy, right? So if, as long as it is a number, NumPy is sort of not warning you, it is creating those values. But you can still check the data type. Let's store it in a variable. And if we check the type of A, this is NumPy ND array. Okay, what is ND? N is for like N is a number 1, 2, 3, 4. It can be, and D is for dimension. It can be one dimensional array, two dimensional array. And if you want to look at the individual data type of the members, and here in this case, I've created an array. The data type is int64. There is no point checking data type of all individual members because they are going to be the same. Let's move on to the next thing. Now remember that when we checked the data type of the array itself, it was ND array, okay, n dimensional array. What is one dimensional array? What is two dimensional array? What is three dimensional array? It's a very simple thing. What we have looked at, creating this list and then creating an array out of this list, is nothing but one dimensional array. Now what is two dimensional array? First of all, how do you visualize two-dimensional arrays? Visualization is very simple. You can think of rows and columns. If you have rows and columns, it is your two-dimensional array. Or there is another way of thinking it. An array of array is two-dimensional array. Basically, what you do is you create two lists. Okay. Let's say I'm creating a list. L1 is 1, 2, 3. L2 is 4, 5, 6. Okay, these are my L1 and L2. And if I create one more list, I'm not creating array, I'm just creating list, but just showing you. What I'm doing here in this cell is I am creating a list where the members themselves are also list. If I print it like this, this is my two-dimensional array, because every member of the array itself is an array. And inside those arrays, those are integers. Those are not arrays. It is just the two levels of array. Of course, I can use np.array and this is my array. Now here, the visualization is also simple. And in fact, I created one image for you. This is how you can visualize two-dimensional array. Let's store it in a variable. Let's call it A2. A1 is our one-dimensional array and A2 is two-dimensional array. Now here, there are a couple of things that you should notice. Number one, shape is an attribute. There is no function call like here. If there are no brackets, it's an attribute. Shape is an attribute. Number two, it always returns a tuple. I hope you know the difference between list and tuple. But anyway, here it is a tuple. But there is only one dimension, and inside that dimension there are three members. It has printed simply that. Now, if we are looking at A2, it is giving us two values, 2 and 3. What it means is in the first dimension, there are two members. In the second dimension, there are three members. So this is exactly how we created. We sent two arrays here. This is why you'd see 2 here. And L1 and L2 each had three members. It is a 2 by 3 array. Right? You can also think of rows and columns. There are 2 rows and there are 3 columns. Now, in case you have a question in mind that what happens if you take different number of values. If you try to do that, you will get a value error. You cannot do that. The number of rows and columns have to be consistent. Now be careful not to use the length. If we check the length of A1, remember that A1 is actually one-dimensional array. Here we knew that, okay, there are three members. This is fine here. But if I check length of 2, then it is returning me 2. What it means is actually len is only going to return you first level depth. The next topic is about indexing. If you're already comfortable with indexing in list, you will know the indexing in array works the same. For example, from this list, if I want to select, let's say, member number 2, then I just have to pass 0 and 1. Member number 2 is actually the number 1, and that's how I can reach that specific member, correct? Now, arrays also work the same way. If I just change it to A1, you will see that I will get exactly the same value, and it is also showing me the data type along with it. Good, we know that the member is actually an np.int64. Now, a little bit more challenging part is the two-dimensional array. Let's say that I want to select number 5. How do I reach it? Now, if you remember, A2 is nothing but an array of array. If I select the first member, I will get another single dimensional array. I'm reaching this one. But where do I want to reach? I want to reach here. I will simply change it to 1. I got my array. Now, from an array, if I want to select the second member, how do I select it? Using the square bracket and index 1. This is returning me the first one here. There we go. I hope this part is also clear. This is getting me the row and this is getting me the column. Let's talk about three-dimensional arrays. This is how we created one-dimensional array. 1, 2, 3. Then we took two arrays which were one-dimensional, and we use these to create a two-dimensional array. Now, what is three-dimensional array? A three-dimensional array is an array where its members are all two-dimensional array. This was our A2. I'm going to make a copy and let's call it A2B. And this time, let's use completely different values. Now, if I create an array out of these array, this is a two-dimensional array. This is another two-dimensional array. Now I'm creating an array where both the members are two-dimensional. Let's press enter. And what you got yourself is actually a three-dimensional array. Now it is a list, of course, but what I have to do, np.array, and this is your three-dimensional array. Now, as you can see here that there are three brackets. It starts with three brackets, it ends with three brackets. Let's store it in a variable, A3. This is 2 by 2 by 3, which means that the first level of array contains two members. Each member is going to be two dimensions. Now let's add one more member here, which will make it a little bit more interesting. Let me re-execute all these. This is A to A, A to B, A to C, and I've created one array, and now this is massive. And if I look at the shape, now this is 3 to 3. So what does 3 mean? It contains three members. Of course, it contains three members. Each member contains other two members, and the last three is actually talking about the individual integers. Now, the innermost number, these three number will not be an array by itself. This is individual members of the array. If we talk about indexing, let's say that I want to reach this number 11. This is going to be fun. If I look at the first member, what I get? 1, 2, 3, 4, 5, 6. This array. But I want to get the second one. Okay, this is my second one. Now from here, I don't want to get the first one. I want to get the second one. Again, second one. Okay, I got 10, 11, 12. And out of this, if I want to reach 11, I'll have to use one more pair of bracket. Okay, so this is how I can reach specific element. Similarly, if I want to reach 18, I'll have to use 2, 2, 2. Now to visualize this, you can think of this picture where 1, 2, 3, 4, 5, 6. Here, this row is an array. This is another array. And combine these two, this rectangle is an array, there is another array, there is another array, and this all together makes it three-dimensional array. Let's say that I want to reach this number 18. How do I reach the number 18? The first thing that I have to do is I have to reach this array. Okay, this is our A3. How do I reach this array? The index is 2. Okay, fine. Now inside index 2, I have to reach to the row number second. How do I reach the row number second? Using the index 1. And inside this, I have to reach the third value, which is, right? Let's see one more example. Let's say that I have to get this value 8. How do I get the value 8? First of all, I have to get to this array. How do I get to this array? Using the index 1. Okay. Then inside this array, there are two arrays. Out of that, I have to get to the first array, which is 0. I go to this array. And then inside it, I have to get to the individual member, which is at this location. As an exercise, what I would like you to do is go to the description, download this notebook that I have created for you, recreate this three-dimensional array with different values. Try to reach all these values, and once you do that, you will be able to understand arrays little bit better. It's important that you learn these arrays. Otherwise, the next video, which is going to be about more functions related to these arrays, how will you understand that? So that's it for today's video. I'll see you in the next one.